Yeah, how's it going, mate? I'm Obsidian Zenon. So, recently on YouTube, there has been a lot of videos about people building VLF receivers. Now, this was very interesting because I would think that building a VLF receiver would mean people would be interested in listening to submarine communications, because that is what the VLF frequencies are mainly used for in terms of communication, because VLF penetrates a reasonable depth of water. But when I looked into it, that's not what they're being used for. They're being used to receive electromagnetic pulses generated by lightning, which are called spherics, and they're spelt like that. It's short for atmospheric, so take your pick on the spelling. But when lightning strikes, it generates quite a broadband EMP. If you're into amateur radio, you'd know what I'm talking about. If you're on any HF frequency, you would experience interference on pretty much all frequencies as soon as lightning strikes hit. And the electromagnetic pulses travel for quite a while, so basically you can listen to lightning even very far away, possibly across the country or things like that. But there's no demodulation or mixing or anything, because you are just listening for a pulse, and this is in audio frequencies 3 to 30 kilohertz. So there's no intermediate frequency or anything like that to worry about. So it's literally just a low noise audio amplifier that you connect to a long antenna and listen for lightning. I reckon it'll be a pretty easy thing to just make and have a play around with. Also, I'm not going to be able to have this next to power lines or near houses or anything, because the 50 hertz mains affects this quite severely. Alright, so I think this is it. It's just, like I said before, it's just an audio amplifier with some, relatively high gain. This is times 200 gain. I was going to do times 100, but I accidentally did two 10k resistors instead of one, so now I have times 200. So more gain, I guess. And this is an LM833, so it's a dual op amp. So I have 20 times gain on the first op amp, and on the second op amp I have 10 times gain with a class AB output stage. And on the input I just have this passive bandpass filter that just filters the 3 to 30 kilohertz range. I probably don't need it, but just to get rid of any unwanted components of a signal that's being picked up, because I'm not going to have an antenna that's several hundred kilometers, not 100 kilometers, but several kilometers long. I would need for frequencies like this. So this is it, and I'm just going to hook it up and see what we get. Sorry about that, I forgot to add a AC coupling capacitor on the input there for the thing. So anyway, what I've done is I've cobwebbed this circuit together with some crocodile clips, and yes, cobwebbed is a technical term. The signal generator is set to maximum, but it's feeding through this 1,000 times voltage divider, so you got a mega ohm here and a kilo ohm here, and the signal comes out into this bandpass filter, then through to the amplifier, and then all through this stuff. So I will show you the output on the oscilloscope. So if I just probe the output there, you can't see anything because it's ground coupled. Right, I had to change the voltage per division, but you see it's a pretty noisy sine wave, but I can't seem to hear any noise when I plug headphones into this, and it has got a decent audio output, so I don't think that noise should be too much of a problem. But this just shows it works, because if I go to the input, even if I go to the lowest volts per division setting, I can't see anything on the scope. So it is amplifying, it's just not super low noise, but this will work. Here's the tin that I'm going to use as the enclosure, because it's all metal. I think it's aluminium. I sanded the face off because you can see it had a design on it, but it was just distracting. And inside I have got this mat, which is an anti-slip sort of mat that you put in drawers and cupboards and things to stop the drawer getting damaged and to stop things from slipping. I had a bunch of it, so I'm just going to use it to insulate the bottom of the circuit board from the tin. And I've also got a headphone jack and a switch and a light for when it's turned on. But yeah, that'll be the idea. And I also have this antenna, which I've had for a while and been trying to figure out what to do with it. So it's a BNC, so I can put a BNC on the outside of this and just have this. And this extends quite long. I think it's about 1 meter. So that'll probably be good for VLF receiving. And if I need to, I'll add a ground spike to this thing, but I've heard that you don't actually need a ground spike to do the receiver, so we'll see how we go there. But I do have a lot of room to add extra stuff if I need to, because I'm going to cut this board. Excuse the rooster. I'm going to cut this board and mount it like this and have a bunch of space up here. So I'll drill some holes and do all that stuff. Circuit's done, and as you can see, there are quite a few more components and wires and stuff than before. That's because the circuit I had originally didn't have enough gain. This one has, I think it's a few million times gain. I'll have to double check that. It's probably because I have some losses in my circuit somewhere. I really have no idea, but I had to put a preamplifier before the filter as well, and it's just probably bad design, but it does work. It works quite well actually, and this tin probably wasn't the greatest thing to do because it's left sharp spots. It was, you drill through it and it leaves sharp spots that are hard to get out, and it's quite flimsy, but it was the only metal container I had, so I guess I just have to live with that. And here's the antenna connected through the BNC. And yeah, the volume through headphones, even when inside, the mains hum isn't too loud, so I didn't have to add a volume knob. But yeah, I can still hear the lightning strikes perfectly fine, and it just runs off a 9-volt battery, which I'll probably have to secure in there a bit better. But the great thing about using a tin is you can just put this lid on, and then it's ready to go for the field. Now, to record this, I'm going to attach a speaker to this instead of headphones, and hopefully you'll be able to hear it. I'm not going to be able to do it today at the current time of recording because it's quite windy outside and that will mess with the microphone. But this thing is quite amazing. I can hear my own footsteps, I can hear the lightning strikes, I can hear different sources of mains hum. I didn't realize that the mains hum makes it halfway down the property, possibly further, through a tap that has copper piping, I think it is. It's metal piping, and our mains is earthed through to that metal piping into earth. But yeah, I'm going to try and record all of that through a speaker on the top. We'll see how we go there. I thought I would do just a quick overview of the circuit in case some of you wanted to build this. It is a very simple basic circuit that could definitely be improved, but I thought I'd still go over it anyway. And I couldn't be bothered to do a drawing in KiCad, so I'm at the whiteboard, which is in the corner of my room, along with this big roll of RG213, which is for a separate video about amateur radio. Anyway, I'll go straight into it. We start with this antenna, which is just the BNC telescopic antenna, and it goes into an inverting amplifier with a gain of 10, and then into another inverting amplifier with a gain of 100.
and this comes down into the bandpass filter. So I actually, for some reason, this didn't work without this preamplification section before it. No idea why, and other people haven't had to do that, so probably bad design again. But anyway, moving on, we have a gain of 20 here on this inverting amplifier, and a gain of 150 on this inverting amplifier that also has a class AB output stage. This is just a BC 547 and 557, and two 1N4148 diodes, similar to my audio amplifier, in fact pretty much the same. And then this comes down into 200 ohm resistors. So because I like to listen in both ears for headphones, I just made it go into both channels with 200 ohm resistors just to separate the two speakers, and two decoupling capacitors. And there's the whole circuit if you're interested. But yeah, there you go, fairly simple circuit, nothing to it. It again is just an audio amplifier, and I just added an indicator LED and a switch, and yeah, pretty simple, and just powers off a 9-volt battery. Thank you very much for watching my video. What was I going to say? Mind blank. Thank you very much for watching my video. This wasn't really a full project kind of video, it was more of something I saw and had to try for myself. The video does not do this circuit justice at all, and I highly recommend that you build it yourself and listen to lightning, because it is quite satisfying to see lightning strikes line up with what you're hearing from your own circuit. Quick warning, don't use this during an actual storm. Having a long metal object connected to you while there's lightning overhead is a very, very bad idea. You might be okay, but do it at your own risk. I would like to experiment with this kind of thing more, possibly with a better circuit. Whether I'll actually get to doing that is a question of time. Maybe I will, maybe I won't, maybe I'll have better projects to do, I don't know. But it is quite an interesting thing to do. Perhaps there's actually a practical use of this. I mean, there'd probably be one for triangulation of lightning strikes, but apart from that, I can't really think of anything, so any suggestions would be very nice. Anyway, thank you very much for watching. If you like the video, press like, and I will see you in the next video. See you guys.